What is shear failure in materials? Have you ever wondered why some materials fail under pressure while others hold strong? Today, we will talk about a specific type of failure known as shear failure. This occurs when a material experiences forces that cause its layers to slide past each other. Imagine pushing two stacked books sideways. They can slip apart along a plane parallel to the force. This is similar to what happens in shear failure. Shear failure happens when the shear stress, which is the force applied over an area parallel to the surface, exceeds the material's shear strength. When this occurs, the material can no longer hold itself together, leading to fractures or deformations. Unlike tensile failure, which pulls materials apart, shear failure involves internal sliding, often resulting in cracks that form at about a 45-degree angle to the applied load. There are different ways shear failure can show up in materials. One way is through shear fracture, where the material cleanly breaks along a plane parallel to the force. Another way is shear yielding, where the material deforms but does not immediately break. Then there is shear buckling, where the material bends or warps excessively under shear loads, reducing its ability to carry weight. Several factors can influence shear failure. The properties of the material, such as its strength, toughness, and ductility, play a big role. The amount and speed of the applied shear force also matter, along with environmental conditions like temperature and humidity. For instance, brittle materials may fail suddenly under shear stress, while ductile materials may show signs of deformation before breaking. In engineering, shear failure is a serious concern. It can happen suddenly, especially in structural components like beams, shafts, or fasteners. For example, in concrete beams, shear failure occurs when the shear force exceeds the beam's capacity, leading to diagonal cracks that can grow quickly until the beam fails. To prevent this, engineers often use reinforcements like stirrups to increase shear resistance. In metal components, such as cold-worked steel, shear failure typically occurs along planes at 45 degrees to the applied stress. This can be due to excessive mechanical deformation, material defects, or reduced ductility from factors like aging or hydrogen embrittlement. Tooling and manufacturing conditions also significantly influence shear failures in metal parts. To reduce the risk of shear failure, engineers choose materials with high shear strength, optimize designs to minimize stress concentrations, and apply surface treatments to improve resistance. Understanding how shear failure works helps in diagnosing product failures and mechanical breakdowns. This knowledge leads to better material selection, design, and manufacturing processes, ensuring safety and durability in real-world applications.